Welcome to Made Up of Wires, where we have been decompiling Castlevania Symphony of the Night, and we'll be continuing to do so today. We've been focusing on weapon functions, and that's what we're going to continue to do today as well. If you're not familiar with the Castlevania Symphony of the Night decompilation project, you can go to SOTN.z.dev, where you'll find progress on several of the modules for the PlayStation 1 version of the game. The main game engine, Dracula.bin, is almost complete. The Richter program is completely finished. We're working on weapons currently. And then several stages are in various stages of completion, which you can see if you go to the page. You can get to the GitHub repository from a link at the top, where you'll find all the code that's been checked in so far as we progress in decompiling. And there's also a link to the Discord server where we're chatting about decompilation, ROM hacking, and different research that people have been doing on Castlevania Symphony of the Night. Today we're going to be focusing, like I said, on more weapon functions. There's only 13 weapon functions left to be decompiled. And I was looking through the list of them, and there's a few simple ones that I think are good to do live on a stream. But the rest may be getting into more complex things that probably involve me sitting and staring for long periods rather than actively solving any problems. So I think I'm going to choose one that I looked into. Typically I don't choose the function beforehand, but in this case, with only 13 left, many have been basically decompiled except for one or two last tricks to get them finished, and there's some that are just very long. I wouldn't be able to do in an hour and a half. And then there's a handful that I think are ready to be done. So I'm going to flip over, and we'll look for, I think I'm going to focus on weapon 30. We'll look at weapon 30 today. Which is Sword of Dawn. I like to go through as well and see what those are, and if that helps at all in figuring out what the what that code might be doing. Oh, that's interesting. Does the wiki not have an entry for Sword of Dawn? Daybreak. So most of these functions have to do with the animation. We're not looking at the summons necessarily. Usually there's a... Oh, here's the animation for the... That's what I was looking for. So a rather large sword, some minor effects as it's being swung. I'm going to go and grab this function. So we're not looking at the attack function, but one of the other helper functions. So we're looking at the assembly language for this function first. This does have a jump table. Nothing overly complicated though. A jump table just means that there's going to be a switch statement that has, it looks like 10 or so entries in it. And that's how the game manages the state machine for that animation. I'm going to copy that assembly and upload it to decomp.me. Start a new scratch. And we'll start with the PlayStation version, and then if we have to go over to the PSP version for a little more help, we can do that. Along the way, if there's any questions that people have, or there's anything that you'd like to see or know, feel free to chat, and I will try to answer to the best of my knowledge. So the first thing that is interesting about this compared to some of the others that we've decompiled previously on the stream is the decompiler has found a structure that previously was not known. And so we'll have to see where that's being used and if that's going to give us any problems or not. This is a longer function, which doesn't mean necessarily hard. It may mean that we can't get through the whole thing in one go, but we'll give it a shot. So the first thing I like to do, as always, is get the project set up and try to get rid of any warnings or errors. So I'm going to go through and see if this unknown 14 field is being used. So we have var s0, and the var s0 thinks that it's this type. Really what it looks like is possibly an alternate of the primitive type that's used for drawing in the game. And there likely is already definitions for some of these alternate primitive types, and we can look at the context to see if there's any that fit. In this case, I'm probably going to switch back to the header files that are already in the game, and I can do that in GitHub as well. That might be nicer than flipping back to the terminal. But what I'd like to see from the header files is what are the offsets for some of these fields. The ones that are being used in the game here, or in this code, are the ones that we typically see. But then, for whatever reason, the decompiler didn't think that it could use the normal primitive struct. So, like offset 14, for example. Let's take a look at offset 14 and see. Primitive is in the primitive header. So in the normal primitive, offset 14 is just the x1. So primitives are quads. So there's 4 x and y coordinates. I don't see, so offset 26, that should be the z priority, which it is. So far I don't see anything. Unknown 0 is the next field. I don't see anything that would suggest that this is not a primitive. This scaling by a 34 is indicating that the size of the structure in this primitive buffer is 34 bytes long, and that is the size of a primitive. I'm not sure why the decompiler has decided to use something else, or that it doesn't know what that field is, but it seems most likely that it's just a primitive. So I think we'll ignore that for the moment and then continue on. I'm going to mark this as a char and reduce the size of each of these. Just to get this to compile first, and then we'll worry about what it is later. So this value is going to be an array of some sort. We can tell it's an array because we're taking a reference to that variable, or what its address is, and then we're adding some value scaled by some number, in this case 4, so it's going to be 32-bit integers or a 32-bit struct. I'm going to make the assumption that it's 32-bit integers. Unknown 4C actually is the animation field. I think this was recently renamed, and my context isn't updated yet. Actually, that might be unknown 4A. Oh no, it is. Yeah, so this is going to be a pointer to an animation frame. So we'll rename that, and so we know that these are animation frames. This is an array to animation frame pointers, which are 32-bit values. Next is this. So again, we're looking for scaling when we're if we're taking a reference to a variable and adding some other value, it's likely an array. And in this case, it's not being scaled by anything, so it's going to be a signed or unsigned value. We can look at the palette to get an idea of what that might be. In the palette, in this case, it's an unsigned 16, but we are loading an offset of just 1 byte, unless this is being scaled elsewhere. It is being scaled here, which is curious. So we'll go with unsigned 16. All of these can be changed, and they're just assumptions based on the surrounding code. Hey, Project Omega. Nice to have you back. Again, this one, so we're setting the speed. This is going to be a fixed 32-bit value, and we can confirm that by looking at the set speed declaration. I believe those are fixed point numbers. I've talked about it on the stream before, but the PlayStation uses fixed point values, so 16 bits for the whole number or integer value, and then 16 bits for the fractional value. We don't really use that in modern computing anymore, so it's a little different than we may be used to. This unknown 86, so this is offset 86 of the extension or extra data in each of the entities. Let's go look at the entity header and see what that might be. When the extension is being used on a weapon, in this case, self is going to be a weapon, we want to look for the 86th offset in the weapon extension. And this one is a little interesting because it's an entity, but it's not an entity that we know, and it's a pointer to that entity. So the having it come from 86 is somewhat odd. So we'll have to figure that out along the way. Let's make sure that the factory unknown 86 is actually what I think it is. Yeah, it is at offset 86. That's definitely strange. So this weapon entity looks like it may be using an alternate extension than the one that's typically used for weapons. And we can look at the other code that was has already been done there and see if there's anything else funny that might already be set up. The existing function is entity weapon attack is relatively small, so unfortunately it's not going to help at all. That's okay. So we have to make a guess as to what this type might be. It's not being scaled by anything. I'm going to assume that it is an 8-bit value, whether it's signed or unsigned. Is not clear yet, so I'm going to go with unsigned. If you're just joining, we've taken the assembly from one of the weapon functions, weapon 30, which is the Holy Sword, and we're trying to determine what each of the unknown fields is. One thing that I didn't do along the way, which definitely can be helpful, we can go back and undo that. We can look at this, how this data is defined when it's extracted from the game. This data we don't, it definitely does look like bytes. We don't upload any of this data. It's not part of the Git repository. You have to supply your own data if you're interested in working on a project like this. And that's because when we are doing decompiles, this next value looks like bytes as well. This was the next array in the list. And so does the one following it looks like 16-bit signed values. So none of the sprites or artwork or sounds or anything like that are part of the decompilation project. We're just trying to go from assembly language to code, and that transformation is a creative process. If you've been on the stream before, you can see that sometimes lots of different versions and iterations of the code result in the same assembly that's being created. So we're not recreating exactly what was used to build the game, but an interpretation that ends up producing the same binary result at the end. So that'll get us a little closer. We still have a bunch of errors and warnings. And that's because there are some void pointers that were generated by the decompiler. We have a little more information, though, than we did before. Let's look at this frame property as well. So I often take this time to, this will be an array. I often take this time to take the things that we've learned and move them to the context. And the decompiler will look at this context when it's doing its decompilation work and try to make inferences based on that and see if we can get rid of any of these void pointers, but that didn't help at all. But this may be slightly closer to what our target is. So we have this target assembly. This is the assembly that I uploaded into decomp.me, and our current one is empty because we don't have a compiling project yet. That's exactly, yeah, I'm baiting and switching people into, Biz Murphy mentioned that I've tagged this as a SOTN stream. The thing is, on Twitch, there's like maybe 12 SOTN streams happening at any time, whereas most games will have like 8,000. There's not a lot of interest in SOTN streams. So for the 12 of you who do enjoy watching SOTN gameplay, you're getting a treat in seeing SOTN decompilation. So I'm just putting placeholders there again because the decompiler thinks this struct is important. It's not actually using this struct anywhere. I'm not sure why it was generated. It's exactly the same size as a primitive, and so it will be a primitive. And that's actually what the next issue is that we need to resolve, is that we have these void pointers. A void pointer in C is a pointer to some data that we don't know what it is. It could be a pointer to anything. And so we can't access fields directly from a void pointer. We'd have to cast it to something else, but the decompiler goes in and kind of helpfully points us to the offsets that we're going to need. So we need to go through, these are going to be primitives. So I'll start the arduous process of fixing these references. Off screen, I'm going to be loading up that same primitive header that I had opened earlier, just so that I have a reference to those offsets, because I can't remember them all. And this is going to be just a relatively mechanical operation of setting the field names to the appropriate things. If you're interested in how I'm getting these names, again, this is in the include directory. There's a primitive header file. I'm just taking these offsets and transcribing them based on what M2C produced. Not particularly creative or interesting, but necessary to get through these errors. We have quite a few to get through. Apologies for this. Enjoy. Hopefully you can hear some Nier soundtrack in the background. A much more epic soundtrack than the task at hand. Oh, now we get to do it all again. These do at least somewhat similar order. It looks like they were extracted. Not exactly, though. I missed your message, Krutafar. Hi. Nice having you in the chat. Good to see you back. It's always nice. This is a relatively mundane process. It is interesting, and obviously I enjoy it, coming back every day and doing some more of it. I find it interesting that other people find some enjoyment enough actually to come back a second day, and or third or fourth or many weeks of watching decompilation. I appreciate it. So we're almost done with these, and then we can get on to more interesting work. I've had many opportunities where I could have written find and replace rules now that would have probably sped this process up. I didn't realize that these would be repeated as many times as they were, and now I feel like I'm in too deep. I see our warnings ticking down though, so we're nearing the end. Oh, drat. Screwed that one up along the way. We'll have to go back and see. Can I get back to that one? Offset 22. It's Y2. Oh, right. 225. Almost done. So now we're back to entity. So we're looking at the offset 50 of an entity. That's the animation frame index. Again, somewhat odd that the decompiler couldn't determine that. This one's a little interesting, and I can do it now, but I could also wait till later. In this case, and this could be why the decompiler didn't catch it, the animation frame index is a 16-bit value, but it's being compared against something that would overflow 16 bits by, in this case, just 1 bit, but it is being compared against a 32-bit value. And when the GCC comes through and compiles this, it sees two 16-bit values that are next to each other in memory and pulls it in as a single 32-bit value and compares them both at the same time. So we have the animation frame index, but we also have the animation frame duration immediately after. So this is going to be a check against both of those simultaneously, and the compiler just brought them into the same statement, so it could do one 32-bit compare instead of two loads and 2 compares. And the same thing again is happening here. I'm not sure. I feel like I always get these wrong in which order they're in. But when this is compiling, we can see if that order is correct or not. All right, a few more of these. So Critifar mentioned the Star Fox 64 decomp, and I haven't looked at any of the N64 stuff. We're using obviously tools that came from a lot of the N64 work, and I think a lot of the work there piqued a lot of interest in general in decomp, and made a lot of that N64 games and decompilation process, and I don't know if porting is the right word, but the magic that's being done with retargeting some of those really into kind of the forefront. And it's nice now that we can kind of leverage a lot of the tooling that came from that. All right, so SP10 is going to be a collider. We can go up and look at it here. And again, this is a case, I've seen this before, where the mechanical decompiler comes through and it knows that this is a collider struct, but for some reason it doesn't pull out that this is comparing the first field. Hi, I'm Lucy. Good to have you. So that's the effects field of Collider. And we probably have a few more of those as well. I'm doing good. We're getting down to some of the last weapon functions, and they're getting harder and harder. So it's nice to be working on it. Glad I am, but at the same time, I hope we find some success today. Success has been hit or miss in the last few days. Yesterday when we were decompiling one of the, I believe it was a function in weapon 50, and now I'm not recalling which weapon that was anymore. We got to everything but the registers that were mismatched. And then off stream I took it and compared it to the PSP version, and was able to go through and rewrite some of the statements to get a match there. But I'm hoping that we get a little closer today. So we're down to just a few more. Line 380. We have another one of these access to effects, and finally on 410. And then we should have an initial compilation to try to determine how close we are. So this is the same duration frame index optimization that was done. And so we have a compile. This is pretty far off, even for, there's some other cleanup that we have to do first. But for our first pass, this is pretty far. And so we'll have to see how quickly we can converge. There was one other, well, there's a few other attempts at this that I found in decomp.me. And I think the next closest was around 84%. So after we get some of these other globals converted to their struct access equivalents, we'll see how close this is. I'm used to Vim where I can type in the number. I did have Vim mode turned on, or VI mode turned on for a while. But it's VI mode in most editors is kind of uncanny valley. The next is looking at GAPI. We access this through a struct as well. So changing all those from the global symbol to struct access. A little closer, but not the greatest. So there is a long and lengthy list of variables to start going through and determining what they may be. I think I'm going to start with the step. Today I've been streaming for it looks like about 36 minutes. Are you talking about today or always? If always, I've just started a couple weeks ago. Prior to decompiling SOTN live, I played Overwatch poorly live. Definitely not the best first-person shooter player, but I enjoy Overwatch quite a bit, and that's most of the gaming that I do outside of SOTN at the moment. My kids play as well, and so it's a fun time for us to spend together. So the primitive values, we're going to use the same variable for both of those throughout, and so I'm just going to do a global replace for those. Just making sure that nothing else is using a var 0 prefix. I'm not sure if I want to start with this top statement. We may as well. So the params is being pulled into a separate variable, but that variable isn't being used until much later. And it looks like params is being used both down here as well as kind of an alternate form that's been masked. And typically we give that masked params the name params, or maybe an index of some type. In this case, temp v1 is being reused, and because various fields are being set on the self entity, or the weapon entity, I'm a little concerned that replacing this with a direct call to, or direct access to params, is going to result in another read that wasn't originally there. We can try it. So we're looking at this assembly here. This is a little early for me to get into the weeds on the assembly that I care for, but if I look at params here, where do we fail? Yeah, so this is going to introduce a load that wasn't there, and that's because we're setting other fields on that self entity, and GCC, even in its optimized state, isn't going to trust that none of those overwrote that field. So I'll pull this out, and we'll call temp s4 some index. Temp v1 we'll call params. I'm not sure, so temp s4 then is, we're going to be using as an index this unknown 84. So if we're looking at the parent, I'm looking at, so the parent is not going to necessarily be a weapon. I'm going through some of the other or it's possible that this is not the weapon, and that it's a child of some other type. Unknown 84 in weapon is a pointer to another entity. So we don't know what this is necessarily yet. But it is being used as part of an index to, for example, the palette. So let's just call it weapon index. This particular weapon is only marked as being the Holy Sword. However, the Holy Sword, if this has to do anything with some of the summons abilities, has a lot of different summons, and so this may or may not be related to that. I'm not sure yet. I'll come through in a little bit and clean up that array access as well. This renaming portion is just to help me understand a little better what may be happening, to follow things as we go along. The temporary names given by the decompiler all get mashed together for me. I don't really do a good job of keeping those straight, so I like to give things real names. Let's look at this next one. Down here we're doing a decrement on field unknown A4. Unknown A4 is also unknown for the weapon, but we'll access it as a weapon. Any of these self extra field access or extension. Those are going to be dependent on the type of entity that is being worked on. So that allows us to get rid of temp v0. I like to start pulling up these variables as well as I name them. If they're going to stick around, it's nice to have them separated. And we can look over here and see if things are converging or not. This var S6, I believe, is going to be one of oh no, it looks like a flag. I thought it was going to be used for the incrementing variable in a for loop, but in this case it's not. It's a flag that we'll need to check later. Let's get rid of some of these casts. So in the original there's a and. That is missing. And the and is coming from v1, which is a stack variable that we don't know what that is yet. Or maybe this weapon index. Odd, however, though, that or params. Yeah. Thank you, Biz Murphy. Yeah, so it's getting associated with this line, but it looks unrelated to this line. So we'll ignore that for now. With the optimized code, it can be difficult at times because instructions will get pulled into lines that really don't have anything to do with those lines whatsoever. And the debug symbols, at least in this version of GCC, don't necessarily accurately give you the line for what the instruction is, especially in these multi-line conditionals. So here again we're going to do anytime I'm a little hesitant to start down this path because it may be messier than I expect. Anytime that we're accessing the extension on self in this case, we should be doing it through the weapon member of the union for this extension instead of factory or something else. I will do the replacement just to see how messy this is going to be. This function is a bit worse than I was expecting. So this unknown 86 is the issue that we were running into earlier that I talked about as I was kind of scanning through. We have an offset, a field at offset 84 in the normal weapon entity, and that offset is a pointer to another entity. Offset 86 doesn't have a meaning in the standard weapon data in this union. So it's going to be, or seems likely that this is going to be a variation of that weapon structure. That's going to have some fields in different fields than what a normal weapon would have. I can replace all the parent access while I'm here, and that's not going to change code coverage or anything. It's just going to make it nicer to read. Let's keep going down. So we're setting the primitive index here. This is pretty common for the decompiler to do, and a relatively mechanical change. I should have snippets for a lot of this stuff. I doubt it's something that would be valuable to bring back to M2C, but for our project we see this quite a bit. And then continuing on, so I'm going to check the opposite side of this condition. So if the primitive index is not -1, it means our allocation for primitives succeeded, and we can go through and set those primitives to do all the drawing that we need to do. If it is -1, however, there's a bunch of different things that might happen. We might just return from the function because it was just related to drawing and doesn't have anything to do with game mechanics. But we also might decide that we need to destroy this current entity. So we have to go all the way down, and in this case that is what we're doing. We're destroying the entity. There's some added complication here in that this is a go-to for several other cases. So I am going to take this and flip that condition above, but I have to do it with some care because I don't want to break these go-tos that are going to block 81 yet. And I might invert that order then to make sure that that doesn't get broken. So in all these cases, the go-to for block 81 can be replaced just with these two lines: destroy entity and then return. And it'll produce the same code. And it turns out that there was one of them. So GCC decided that when it saw this very early on, that it was enough to optimize this to be a branch in the code instead of duplicating this code. And in this case, that optimization doesn't seem like it was worthwhile. There is a very interesting default label in the middle of all this. This likely will be moved to outside of our switch statement, and the cases will either return prior to breaking or coming to the end of their particular section of the switch statement, or they will break and go out of the function and then execute this code. My guess is that many of them are going to have a go-to and go to that particular block, or return immediately. So we'll get rid of that, and then we have to follow this down and find where that was. So let's look at that as well. Let's see who is going to block 83 at the end. So case 1 finishes by going to block 83. Case 2 does as well. Case 3 does as well. Case 4 does not. 5 does, 6 does, and 7 and 8 do. So this is like I thought. Everything in this block 83 can be moved to the end, and so we'll follow that down. And then our default condition will fall into that as well. And that may or may not help our coverage. It did quite a bit. So let's go back and see where we were. So we were at 48%, and that brings us up to 73%. And then all these cases where we're going to block 83, we can just fall through to the end of that switch. Unrolling some of these go-tos, not only does it get you closer to what the original code was, but it makes this much easier to read as well. We have a else return here. We can see if that, if we can get rid of that as well now. So we're saying if this value that we're not sure what it is yet, if that's equal to 1, we're going to continue. So let's invert that as well. And we can get rid of that condition. That may or may not be correct. But in the meantime, reducing the nesting makes it easier to follow. That did get us a little further back. I'm not too worried about that at the moment, though. And then we had one other, maybe two other go-tos. So this looks pretty common. So in this case, we're setting this unknown 7E. 7E is also unknown for the weapon. The field name is the same, so we can replace all those while we're here. And this is another case where the compiler decided that this making a branch to this particular logic was more optimal than just repeating the code. So one of the things we need to take care of as well as we're going through and replacing all these, the original block 78 sets these two values and then breaks to the end of the switch. So you just need to be careful that that's what we're doing as well, and making sure that that's how these statements are going to end. So this is one of those cases where it wouldn't necessarily have done that if we got to the end of this condition and didn't add a break or something else or other conditional structure. We would fall down and we'd decrement the timer, and that's not what we want to do. So one option is to wrap this in a else, and that will give us the same logic. Otherwise, I could have added a break at the end. I'm going to make the assumption that this is the way that this was written, but we'll see as we continue on. Okay, so we've gotten rid of block 78. That didn't, it changed the match a bit, not significantly. This is a pretty small, comparative to the function, this is a pretty small change. Let's look at the last go-tos. So we have 1 to 61 and 71. Block 61. This is slightly more complex. I'm going to leave that one in place now. When there is this much that's being executed, we can try it. Let's look at the assembly first and see if there's a big gap in this section. So we're looking at around line 280 or so. So many of our instructions are quite a bit different already. But that may be caused by... I think we're still too far away to make a determination about that. I'm going to leave that one in place and then come back to it when things get further along. So the last one is this block 74. And that is a simple one as well, just decrementing the timer. And then breaking out of the switch statement. So in this case, if this condition on line 307 is correct, we're going to do all this, and then we're going to decrement the timer and leave. If this condition wasn't true, then we're going to execute this code. So we can rewrite this slightly and get that same behavior. And this is a good time to also rename this field. And we can get rid of this as well. Okay, so I think that takes care of most of the control structures, or at least the conditionals and that switch. Come on. I'm going to go through, I think, and fix the loops next. Anything that makes it slightly easier to follow up front, I think, is helpful. So anytime, in this case, anytime var_3 is being used, we're going to treat that as a standard for loop and use I as our variable there. I'm just going to... let's see. So I want to rewrite this as a for, and we're only doing this once while we're less than or equal to 0. All right. We'll have to check that out later. And we don't have an I yet. Here, when we're getting a reference to the primitive object, that's going to be array access. That's something I go through as well, fix many of these pointer arithmetic to array subscript operations. So in this case, we are iterating a random number of times. And it's possible that this this check here, this may not be necessary. Often by this time we're far enough along that there's different matches. The code is matching enough that we can tell whether or not this is necessary. I'm going to try to get rid of it. The for loop will take care of this. That looks a little better, so I don't think that was necessary. And we can get rid of this var 3 underscore 5. Here's another less than equals 0. My guess is that that was a constant that was pulled out at some point, and later it was determined that for whatever this operation is doing, that they only needed one of them, but the loop was already there and it was configurable. So that got us a few fractions of a percent, not much. All right, so what should we do next? This var 6, I'd like to give a name, since it's at the top. Something as simple as flag might be useful. It looks like it's being treated effectively as a Boolean, and it's a flag to update the animation or not. And we'll look for that, and it looks like it's either true or false. For those who aren't regular C programmers, up until recently there was not a true and false in C. They're not keywords. Interestingly, this is used inversely, so don't update animation might be the more appropriate name. We'll call that no. Even now, I believe true and false are just type def to 0 and 1. C++ does have keywords for true and false, and most programming languages other than C do. Most old C programs you'll just see 0 and 1, and no macro or anything like that used in place. Alright, so I'm going down and looking at some of the other variables that aren't named yet. This temp_s2 is being used to augment the index to this palette array. Sorry, it's not the index to the array, it's the palette value itself. So it's kind of a palette offset. Going through and renaming things isn't going to help get us any closer, but it does help determine what might be going on. So rewinding, about 20 minutes ago or so, Biz Murphy mentioned when I was looking at the assembly that's being generated up here, there's this AND versus hex 1000. That's down here on this line 84. It's easy to become kind of myopic when looking at this as well, especially while trying to explain it and kind of grokking the context of everything around it. But the compiler has decided that it's going to pull that up here, and there's a couple reasons that it might be doing that. This may happen elsewhere, and it's decided that that's the most likely scenario that's going to happen. I don't see that happening. And it's also possible that some of these other instructions are out of order and may need to be pulled out. I'm going to leave it where it is, however. Unknown 5a is not obviously known, so we'll leave that. Let's look at these var a0 and how that's being used. So this is being set to our v value. So I'll rename that v. And var t1 is likely... Oh, no, it's not the u value. It's the color lookup table. Oh, not cut. We can look at some of these and see if there's anything obvious in the assembly. So our ordering of the assignment for these fields is off. That could be for a couple different reasons. It could be the way the assignment is being done. It could just be that they're out of order. Typically this line is out of order. I don't want to spend too much time there, though. So this setting the temporary variable, this is one of those cases where we can set the assignment here, and both on the PSP version and the PlayStation version, these should end up compiling to the same thing. This temp A1, because V doesn't change whether this was actually did happen outside this. So this is an interesting thing that happens with optimizing compiler. So we have this temp A1 value, which is the value that is being stored in register A1, and it's set to V which is logically ORed against 5f. The compiler knows that these are local variables that are private to this function, and because they can't be manipulated, they may be on the stack, they may be in registers, but because they can't be manipulated by anything outside of this function, and even if we set something on a pointer, they're not aliased to anything else in any way, that even if they're inside the function here, they can be pulled out and calculated once, and those values can be reused without harm of any of these other assignments that are off to some memory address somewhere affecting them. So cleaning that up, there wasn't a lot that I did that was novel or interesting, but it did clean that up quite a bit. There still is some ordering here. These may be out of order still. I'm gonna off screen. I'm gonna look at the typical order of those, because I can never remember what that order is. So often the draw mode and, the lookup table and T page are set earlier. Let's see what happens if we move them to the top. So they're not at the top. We can move them back. Oops, pulling the wrong thing. After the positions. Let's look here. So we're looking at offset 12, and we need to find where offset 12 is getting set in the original assembly. I'm not seeing it. We could look at 1E as well. Oh, that's because I'm misreading these values. The addresses are being stored in is that right? Being stored in that T3 register. Yeah, so these offsets are that I'm looking at here are offsets from the stack, not or offsets from this S0. I'm going to keep going. Those offsets being so different is a little odd to me. So this should be storing the value of A3 into the primitive offset 34. However, it's possible that my context is wrong. Yes, that would help. this was my context from PSP, and all these fall into place then. I had extra padding in there. The PSP has an extra 32 bits at the header of the primitive, which I had in there. And I'll do this instead of getting rid of it completely. I'll add a check for it. Alright, so then most of that is in the right order. These look like they are not. I'm not going to worry about them though. If this doesn't work, I will correct them at another time. Oh no. Why did this fail? Okay, that looks like that worked out. So now we're going to do the same thing down here as well. I'll come through and clean some of these up here, but this looks like it's going to look largely the same and have very similar modifications, which will get a little closer again. I was just so most people coming into PlayStation programming are probably familiar with a general coordinate system, XY coordinates on a 2D plane. One that I was not familiar with was the UV notation, which is used for textures. And basically it's an X and Y value for textures. And I finally had to look that up yesterday to give myself a better idea of what I was looking at. 105, I screwed something up. Alright, so slowly getting closer. This one will take quite a while. We're running up on about an hour and a half, and probably a little less than halfway done with this decompile. I'm going to move these back. It looks like I had screwed something else up along the way. So that order needs to be fixed still. There we go. But the rest of this should hopefully kind of slowly shake out in similar form. This one is going to be kind of a methodical replacement of many of these temporary variables with some meaningful names. And fixing some of the ordering and logic that the decompiler produced. So this one's still quite a way, though, from being finished. If you'd like to know more about what we're doing in this Castlevania Symphony of the Night decompilation project, I will kind of go over this again. We were looking at Sword of Dawn, which on its face looks like a pretty straightforward sword for its normal attack, but the summons get relatively complicated. Unclear still if this is related to that at all. If you want to know more about the Symphony of the Night Decomp project, and your browser can load things faster than mine, you can go to sotin.z.dev, where you can see the progress of the various objects that are being decompiled. There's also the GitHub repo at Zynamo SOTN Decomp, where all this code will eventually exist. And you can see progress there as well, along with active pull requests, open issues, and other things like that. There's a lot of work being done by a handful of excellent contributors that are going through and finding out a lot of details about the game, and kind of working on standing on some of the research that's already been done into the game from the past up until this point. Other than that, that's all I have for today. Again, so this is, I mentioned at the beginning that this is going to be a hard slog to the end of the remaining weapons, but it's just time consuming. Nothing is impossible or insurmountable, so we'll get through this as well. I think tomorrow I'll probably move off of weapons because I believe the others are going to be a lot like this as well. They're just going to be long, and there's not a lot of detail or interest. It's more just the process of replacing variables and working through different things. So tomorrow is Thursday. Thursdays I like to do things different anyway. I think what we'll do is set some breakpoints in DuckStation and go through and try to name some things. I've been wanting to do that for a while, and I think tomorrow is as good a day as any. I'll still update every day until weapons are done, or this weapon 0 object is finished. If there are any comments, questions, insults, compliments, feel free to put them in chat. You can check out previous versions of the stream on YouTube. There's a Made Up of Wires channel there. It doesn't have a nice name yet. Watch them there and give me views, and then I'll get a nice name on YouTube as well. Follow. I'm still planning on doing this Monday through Thursday for the foreseeable future. And yeah, I'll see you tomorrow. Adios.